we're going to look at rules of exponents. So to refresh our memory, for the rules of exponents, we have several. So the first rule is if you have x to a power, x to the m, and then you multiply by x to the n, your result will be, so we add those exponents, so it's x to the m plus n. And so in this one, when you multiply the two exponentials, we are adding the exponents. Second rule is if I said x to the m and I take that exponential and raise it to the nth power, that gives us, and this gives us, you multiply them and you get x to the m times n. So we are multiplying exponents. Third rule involves taking an exponential x to the m and dividing by x to the n. For this one, I'm going to look at x to the m and x to the n, and I get here x to the m minus n. It's the top exponent minus the bottom. So for this one, we are subtracting exponents. Now, there are some other rules which some books call by definition. For example, x to the 0, we know that that is 1. And if we wanted a proof about why that is, if I said x cubed divided by x cubed, by this rule where we subtract exponents, this is x to the 3 minus 3, which is x to the 0. But x cubed over x cubed is just the number 1. So that's how we get that result. Another rule that we have defines for us what negative exponents are. So if we say x to the negative m, where m is positive, that's defined to be 1 over x to the m. So a negative in front of the exponent is a reciprocal. To clarify again, a negative of a positive number minus a positive is a reciprocal. It's 1 over. And the last rule that we can think about is if I say you have x to the m, y to the n, and you raise it, the whole thing, to the kth power. So this is very much like what we did up here, which was this power rule where you multiply exponents. So here we're going to get x to the m times k, y to the n times k. We're just using this multiplication of exponents on both of those bases. We're going to do some examples. So first example, let's say I said you had x cubed, x to the 5th divided by x to the negative 1, x to the 9th. So for a problem like this, you can think of numerator and denominator as if they were in parentheses. So our first step is we have x cubed, x to the 5th. We're going to, because you have the base twice, xx twice, we're going to add the exponents. So this is x to the 3 plus 5, which is x to the 8th. And then similarly, the denominator, we have x base, we're going to add those exponents. So it's x to the negative 1 plus 9, which is x to the 8th. And now that you have x to the 8th over x to the 8th, you can do it two different ways. One way is to see that these are identical, so it cancels and you get 1. The other way would have been to write it with subtraction, 8 minus 8, so x to the 0, which we know is 1. A second example is, now we're going to introduce as a second example, and I'll go to the next page. second example will be x cubed y squared to the second power divided by x to the negative 4 y to the third. For this one, I do the numerator first, and I see I have a parentheses with an exponent outside. That's the signal to multiply the exponents. So we're going to multiply the exponents by the 2 outside. This becomes x to the 3 times 2 is 6, y to the 2 times 2 is 4, divided by x to the negative 4, y to the third. But we've got division, so we're going to have x to a power and y to a power. And we've got to figure out what that power is. And we know about subtraction. That's our subtraction rule. So this becomes upper 6 minus the lower negative 4. Y is 4 subtract positive 3. And sure enough, 6 minus a minus becomes 6 plus 4. And this becomes x to the 10th, y to the 4 minus 3 is 1, and I don't have to put the 1. So that becomes my answer. We'll do another problem where we're doing division, only this with different values. So I have x to the negative 2, y to the 1, raised to the negative 3 times x squared y cubed over x to the negative 1, y to the negative 1 to the negative 2 power. Okay, to do this problem, first we're going to do the exponent here, which involves when you have a parentheses with an exponent, we're going to multiply those exponents. So this becomes x to the negative 3 times negative 2, negative 3 times negative 2, which is x to the 6, and y to the negative 3 times 1, which is negative 3. Negative 3 times 1 is negative. And there's no more power out here, so I just write what I have here. X squared y cubed. Then the same with the denominator. Because it's a parentheses with the power, that is your key, that's your hint that you multiply exponents. So we're going to multiply the negative 2 times both of those negative 1s, times both of them. This becomes x to the negative 1 times negative 2 is 2, y to the 2. At this point, we've got x's appearing as a base more than once. So when you have the base appearing more than once like that, that's going to tell you you're going to add. So we are going to add the exponents here, and we're going to add the exponents here. So doing that, we get x to the 6 and 2 is x to the 8th, y to the negative 3, y to the 3. Negative 3 plus 3 is y to the 0. And down here we have x squared, y squared. But we know that y to the 0 is just 1. So we're really multiplying x to the 8th times 1. So I can write this as x to the 8th over x squared, y squared. And now, anytime you have more than one exponent, you have to continue with your rules. And by division, that means we're going to subtract. So we're going to subtract 8 minus 2. So that gives us x to the 6th, and there's nothing to do there but to leave the y squared there. And that became our answer. Okay, our last example, and I have a cute little way of doing this, is suppose you have x to the negative 7, y to the 3rd, x to the 4th, y to the negative 5. So the shortcut involves, think of it like gophers. If you're above ground and something negative is happening, you quick drop below to get into safety, and it becomes a positive experience. When you're below ground and something negative is happening, you quick pop up and it becomes positive. So thinking about it this way, the gopher in this case, there's something negative happening here. They will drop down and become positive. So the x to the negative 7, it drops down below, x to the 7th, it's positive. Now I look at y to the 3rd. It's positive exponent, nothing negative is happening, so it just stays. So this becomes y cubed. Now I go down here and I see x to the 4th. There's nothing negative happening. That stays. But now, think of the gopher. There's something negative underground, so they quick pop up and it becomes positive. And this becomes y to the 5th, because we've got to get rid of the negative. That's y to the 5th. And now you're ready. We have no negative exponents. Now we're ready to complete the problem. And now we can see there were y's here. 2 bases mean we're going to add the exponent. So this is y cubed times y to the 5th is 3 plus 5. It's y to the 8th. Down here, x7, x4, we add those, and it's x to the 11th. And that's our answer.